Hi friends, welcome to my channel. So in this video, we are going to analyze problem 2095, delete the middle node of a linked list. This is actually a very straightforward problem. So actually in our previous video, we used fast slow pointers to detect the middle node in a linked list. So this problem can be regarded as a follow-up on that video. So here we are going to again using fast slow pointers, but also we want to introduce a trick that is using dummy nodes. So the reason that we use dummy node is because that if the length of this list is 1, then the middle it will be itself. Then we should have something, we should return something dummy. But when we do the delete, we need to use the previous of the middle node and then pointing to the next. So here, in order to delete 3 in example 2, we need to use 2 point to 4, right? And similarly, in example 1, we need to use 4 pointing to 1. However, if the length of this list is 1 itself, then we just need to delete that node itself and return null. So in order to incorporate all the cases, so I would say for those 3 examples, they still not demonstrate the generic case or edge case because here the length can be 1, right? So overall, so what we are going to do is that, so we use slow fast pointers, let's see, to detect the middle node. So here, the middle in the sense of this problem, right? So if we have 2 middle nodes, so we're going to return the second one. And then we use dummy node to help. So this is 2 pieces of obviously technical side here for the coding. So as in the previous video, we have demonstrated how to get the middle nodes. And then for this problem, we just need to do the deletion. In other words, once we locate the middle node, we need also to record the previous node. And then we use previous pointing to the next of the current middle, right? So we can actually directly go to the coding because this problem is so straightforward. First, we're going to use a dummy. So notice that in the assumption, so though the length is very long, can be, let's say 10 to the power 5, and the node value is in between 1 and 10 to the power 5. So I can introduce a dummy list node. So we can instantiate 1, let's say, list node. If you do not write anything, so you are going to have a node with value default to be 0 and next to be none. So here, in order to emphasize this part, in order to emphasize this as a dummy node, I can provide the value. So as long as outside this range, so we can use 0 or negative 1 as you like. So now what we want to do, we want 3 variables. So one is the fast slow pointers, so we have pointing to the height, and slow also pointing to the height, and also we need a previous pointing to the dummy, right? So we can actually regard the dummy is pre to the height, so we can do something like this: next equals height, right? So this next actually connects the dummy with the height. So this is the one way to write. You can also do this, right? You can also do, you have a dummy list node, something, let's say value equals -1, and then you can see dummy and next. You provide this attribute, let's see, height. So this way actually use 2 lines, but this one is 1 line. But for some people, maybe this 2-line operation is more, more digestible, right? So I would say this is dummy node part for here, in order to deal with the case if you have just 1 node in the linked list. And then we use fast pointers to detect the middle nodes. So notice that it's important to connect the dummy with the height in order to make this work, or in order to make this repointing works elegantly. So now we write the while loop, while fast and fast next. So as I mentioned in the previous video, look at the way we write the condition. We write fast first, and then we write fast next. It's because that only when fast is not null, we can talk about fast next, right? So once we have this, we can do the moving forward, right? So previous and slow each time moves one step further, while fast moves 2 steps further. So pre will pointing to the current slow, and the slow will be pointing to the next, while fast will pointing to fast, next, and next. So I want to mention that this way of writing is legitimate, because in the while condition we have fast next is not now. Now that fast next is not now, we can talk about fast next, right? So afterwards, so the slow will pointing to the middle. For example, let's use example 1 as example. Then, so you can print out the slow. The slow will be pointing to 7, and the pre will pointing to 4, I guess. Yeah. So pre, right? So let's print this out. So yeah, this is the pre pointing to 4, and slow pointing to 7, the middle. So what we want to do is we want to break the link, and we set 4 pointing to 1. So you can do this. You can do pre next equals slow next, right? Then you just return dummy next, because dummy is always not now. Then we can always talk about next. If you here pre, it remains dummy. For example, if you have a linked list, just have one node, then dummy will be the dummy, and then dummy slow will be the head itself, but slow next will be now, right? We use dummy pointing to now, then we do dummy next, it's going to give you now. This is right. So this is the one way to write the code. It's actually a short one. So let's do a test. So it passes one example. Now let's look at the generic case. Yeah, it passes all the cases. So this is one way. But if you want to make it more complete, you can break the link between 7 and 1. You can do something like this. So slow next to be let's see, slow next. Let's first point save slow next to be slow next, and then I set slow next to be now, and then we do pre next to be slow next. Right? You can add these 2 lines. You can first break this link, and then when you set pre next equals slow next, you also break this link. So let's test it directly. Let's see what's the problem. Oh, here not slow next. So because we have stored that, we need to use this one, right? So let's test it. Yeah, it passes all the cases, but in the rigorous sense, this is not absolutely necessary. So you can do this. So slow next because we commented that. This is the one way. Let's see, and this is another way. Right. Let's test it. Yeah, that's basically about it for this problem. Then compare with the previous video. No, we just added this piece of information. So from the code level, so we added this one, we added a pre, right? We added this line and this line here. So with that said, I guess that's it for the current video. Thank you.